attack CRM services and SQL injection. Here again, we have Gil Cohen, our research director, that will take us through the attack steps, and Giuseppe will take us through the defensive capabilities that we have. So, Gil, are you ready to go to our third scenario?
Yes, thank you.
Yes. So, good morning, everyone. Gil, do you want to share the presentation for the first slides? Okay. Okay. Again, good morning, everyone. We are approaching to our lunch, but before our lunch, let us to explore the third scenario. I'm Giuseppe Di Pasquale, and I work in Microsoft, and my job is to help our customers to improve their security posture. And in this scenario, I'm going to dress a blue dress to protect the environment of our CRM service against the web application attack. Click. Then my colleagues, before talking about credential theft in several topics, interesting topics, but now we need to move to another surface, attack surface, which are the web application portal, simple website, web portal, the e-commerce website, and especially the line of business application. And in this category falls the CRM we are going to talking about. Click. So against the web application attack, we can describe three types of attack. The first one is the DDoS attack, the most common attack when the objective is to saturate the network link to create a network loss and corresponding to money loss, reputation loss, and something like that. Then the web application attacks, the objective of today, that include all the web attack and exploit you can do for the web application. And in this category, we are going to talk about the OWASP top 10. And for who doesn't know the OWASP top 10, is a no-profit organization which collects all the possibility of web application attack that today we can do. And then finally, the malicious boot. The malicious boot is used for the DDoS attack as well, but even for the content and price scrapers. That is an illegal competitive price monitoring to track valuable information to be competitive with the online prices for the e-commerce website. And now let me switch over the voice to Gil for the attack part.
Thank you, Giuseppe. So as Giuseppe just mentioned, there are different kinds of attacks against web applications and also mobile applications that use web interface and web API at the backstage. And now I'm going to show you the most common attacks. As Giuseppe mentioned, OWASP top 10, OWASP is a non-profit organization that promotes application security with a non-profit. And the most famous project of OWASP is OWASP top 10, which is the top 10 attacks and topics regarding application security. They publish it every once in a while, every 2 or 3 years or so. Since they started, injections attack are always ranked at #1. And the first attack that I'm going to show you is the most common injection attack, which is SQL injection. People ask me, is this still relevant? Because when I first started 10 or 15 years ago, this was very common, and now it's not that as common. And the answer is yes, there are still legacy and old systems and insecure systems. So it is not that common compared to 10 or 15 years ago, but you can still see SQL injection every once in a while. I encountered around 10 SQL injections in the past few months. Okay, so but let's first discuss what SQL injection is for the people who are not aware of this attack. So SQL injection is a code injection technique that exploits a security vulnerability in the database level of the application. You actually inject database code and you change or tamper the way that the database is supposed to work in order to steal information, for example. So usually SQL injection risks confidentiality. You steal sensitive information. In some cases, also integrity and availability of the information in the system. And this is a full applicative vulnerability. Later on, we're going to discuss the mitigation, all of these steps that all of the attacks that I'm going to show you. But in order to fully mitigate all of the attacks, you need to fix your code. Giuseppe is going to show the Microsoft Web Application Firewall, which is an additional measure, but in order to fully mitigate, fix your code. Okay, so how does SQL injection works? So practically in every web application out there that contains a login mechanism, you enter your credentials, and you can see that this is what is being sent to the database. This is a SQL query language. This is the query language that is used by databases. Select star give me all of the columns from users from a users table, where username equal my user and password equal my pass. If I enter a right set of credentials, my user and my pass, these are a right set of credentials, then this query will return a single row, and then the programmer would know that I entered the right credentials and let me in. If this is not the right set of credentials, then there isn't a single row where the username is my user and password is my pass, then this query won't return any results, and I would see an incorrect credentials message of some kind. So what happens in SQL injection? Instead of entering regular set of credentials, you can see here that I enter SQL code that is actually affecting the way the query is being executed. So here you can see that, let's see what happens here. Select star giving me all of the columns from users where username equal my user and password equals, take a look at what's happening here, empty string. I close the string that is started by the programmer, or 1 equal 1 minus minus. Minus minus is a comment. Everything after minus minus is being ignored. So I'm actually sending a query to the database asking it to check all of the user table and get a single row where the username is my user, the password is empty, which obviously this cannot happen, or 1 equal 1. And because this is a true value, what will actually happen is that the entire users tables will be returned from this query, and the programmer's code is not intended for this situation to ever happen. So it actually takes the first value and the first username and assigning the identity of this user. So it has nothing to do with the username I just entered. I would get the identity of the first user in the database. What should have happened if this was not vulnerable to SQL injection? So the attacker would obviously inject the same payload, but you can see here the payload is slightly different, and this minor difference makes all the difference. So let's take a look at what's happening in the password condition. Password equal apostrophe, apostrophe, apostrophe. This is 3 times the character apostrophe. This is not a quote character. In SQL, if you want to put an apostrophe character inside a string, you need to encode it. And the way to encode it is to duplicate it. So basically, I inject as a hacker a single apostrophe value, and the database receives an encoded value, which means search for the actual value of password apostrophe or 1 equal 1 minus minus. And if this combination is incorrect, I will get the appropriate message. So this is how you mitigate SQL injection. You probably ask yourself, okay, let's just duplicate any apostrophe, but this is not the case. This is not the best practice solution. You need for the framework to do it for you. .NET framework, Java framework, etc. You need to follow the best practices for data access layer and for database connection in order to prevent SQL injection from happening, and the framework will duplicate the apostrophe for you. So for the first demo, the hacker will get the identity of the first user in the system, and you have multiple ways into getting identities of other users as well. So let's see it live. So here is the Secure CRM website. This is a fake CRM I created don't try to access it. You won't be able to do it. It's a private address. This is a special website I created with vulnerabilities that are deliberately built into it. So the first attack I'm going to do is to try the SQL injection attack in the login command. So instead of just or1 equal 1 minus minus I just show you, I'll enter a very similar variation. And this variation, the apostrophe of the programmer will close this string. So I'll inject it as part of the username and the password. And as soon as I hit the login button, you can see that I'm logged in as the first user in the system, which is my user. And now I'm able to steal sensitive information and maybe performs different actions, etc. But this is not the most interesting thing you can do with SQL injection, because a login mechanism allows you to steal one user at a time. And I want to steal all of the information and perhaps even conceal the information such as credit cards from the database. So in the next demo, I'm going to steal credit cards from the database. This is ranked number 1 in OWASP top 10 SQL injection, and also number 3, which is sensitive data that is not stored in a secured manner. For example, unencrypted credit cards or passwords that are not hashed. So in the next demo, I'm going to inject SQL injection in another part of the website and steal credentials or credit cards. So here you can see there is a search mechanism, and I can, for example, search for CRM, and here are the search results. And in order to see if this is vulnerable to SQL injection, the simplest way and the script kiddie's way is to just inject a single apostrophe. If there is SQL injection and this apostrophe is not duplicated, you'll have an error. And as you can see here, this is exactly what happens when I inject a single apostrophe. And there are multiple ways. I'm not going to show you the whole path into getting the actual into investigating the database that is behind this website. There are an automated tool for it. For example, SQL map, a very nice utility, and manual ways. I created also private utilities that allows you to extract data from breached databases. But for now, let us just settle with this injection and move on. So the first thing that I would try to do whenever I do a real SQL injection is to get the list of tables. Sorry. So the first thing that you would probably do is to get the list of tables from the database to see what's interesting in here. So I'm going to do it right now. There are 2 columns in the search query, so I'm going to inject 2 columns in here. Oh, sorry. Table name. Okay, so here are a list of all of the tables in the database. Instead of a regular search result, we get these. For example, there are credit cards. So let's just take the credit cards columns. I can do it, for example, a table name and column name from information scheme dot columns. By the way, this is a system table. As soon as I identify that, for example, this is a Microsoft SQL server, I know, in fact, that this table exists. If this was an Oracle database, then I would query the all tables and all tab calls database table, system table, for example. So let us inject this query as well. And now I have the list of all of the table names and their different columns. And the last step will be to get the information itself. So let's do it. Select, sorry, union select. We need the first name and the last name and the credit card from credit cards. And now you can see different credit cards. So this is the more dangerous part of SQL injection and the things that you can do with this attack. Unfortunately, in Israel, we have license plates of cars with numbers only, so this won't work. But perhaps in Europe or in other places around the globe, if a speeding camera or an automatic toll camera will get this license plate, interesting things would happen. So this is a small SQL injection joke. But let's move on, we don't have a lot of time. So the next attack that I'm going to show you is cross-site scripting, or XSS in short. So this is ranked number 7 in OWASP top 10. And this is the type of attack of security vulnerability that enables attacker to inject client-side script into web pages viewed by other users. You are not attacking the server anymore, but you are attacking its users, its clients. There are several types of cross-site scripting. I'm going to show you the most common two. The first one is reflected XSS, and this attack requires the victim to follow an attack URL, a link. For example, I would send him an email with a link to the real secure CRM website. It won't be a phishing website, the real one, but the link itself will contain the malicious code that will enable me to execute the attack. So cross-site scripting can be used for impersonation, elevation of privilege, target phishing, in some cases defacement. So in the next demo, the hacker sends an email to the victim, and as soon as the victim clicks the email, the hacker is able to steal his session ID, for example, from the cookie, to steal the cookie and the session ID in it, and or to redirect him to a malicious website, for example, a phishing website, and then harvest his credentials. And in this case, by the way, the malicious website would look as if it is the real website because the address won't change. I can open a malicious website, for example, in an iframe. So let's see it live. So let's go back to secured CRM. So the first condition for reflected XSS is that any input would be reflected back as part of the output. For example, if I put this, you can see the 3 Qs. This is the input, and here it is reflected as it's part of the output. And you can also see that here this is part of the URL, so I can also change it to another value, and then I would be able to, for example, send this link and set the search value for the victim. And let's look at the backstage of the client of the HTML. This is how all internet is actually built. Your web browser is actually executing HTML and JavaScript at the backstage. So my goal as a hacker is to inject malicious code and to change the way your HTML and JavaScript behaves. So let's search for the 4 Ys, which is the current payload. So here it is, it's part of the output. This is one place, this is another place, and this is the last place. And my goal is to inject HTML that looks exactly like this into here. So let's try it. So now I can first try to inject a very simple HTML element, which is BR. This is a new line. And instead of a single line, you would see that now the line breaks. And this is actually treated as a new line element. And instead of just inserting a regular BR element, I can also inject a script tag that enables me to execute JavaScript, and this will enable me to perform interesting attacks. So in this example, I just popped up a message with the character 1. You can see that this is actually execute, and I also created this payload in advance. This actually replaces the whole document. Although I would be in the same page, it replaces it, and I can, for example, inject an iframe that would load a different page, a different website, a phishing website, for example. So let's see what happens when I do this. Okay, so now I'm not in secured CRM anymore. I'm in bad CRM. This could be, for example, a phishing website, and I would enter my credentials. The address would still be that of a secured CRM, and nobody would notice it. So this is reflected XSS. And you probably think, okay, but I'm a smart person and I'm a little bit technical. I'll probably know when someone is trying to attack me. If someone would send me an email with this link, I would see the script tag here and I won't click it, right? What about this? And this one. So these three links are practically identical. This is just one way to mask your attack, to hide your attack, using URL encoding. There are other ways as well, such as URL shortness, bit.ly, and many others. And you probably think, okay, so let's just drop all the less than and bigger than sign and no more XSS, right? Wrong. There are XSS out there that activate without the less than and bigger than sign. For example, if you inject a specific attribute and you are able to inject additional attributes alongside. So, for example, here is an image tag, and you are able to tamper the source of the image, but instead of just changing the source, you inject also an additional attribute of what happens if this image fails to load, then run this JavaScript. And now you have other ways into executing JavaScript without the less than and bigger than sign, and also try to bypass web application firewalls. But this is not the most dangerous kind of cross-site scripting. There are even more dangerous kinds. For example, this one, the persistent XSS, which is a permanent one. This is more dangerous because the payload is actually being stored inside a repository, such as a database, and you don't need to send a link, the link to the attack, to the victim. So the user won't even know that anything happened. I eat cross-site scripting for breakfast, and I won't be able to notice that anything is wrong if a website is attacked using persistent cross-site scripting. So this can also be used for impersonation, elevation of privilege, stalking, phishing, defacement, and denial of service. Just for you to know, British Airways was attacked a year and a half ago with persistent XSS. Their website was injected with malicious JavaScript that stole credit cards from anyone who orders flights from the British Airways website. They got a ticket. It wasn't. It was fully integrated into the flow of the website, but it enabled attackers to steal 300,000 credit cards from British Airways customers, and as a result, British Airways got a fine as a result of the GDPR new regulation of more than 200 million euros. Oh, so, I'm sorry, I think it's 180 million euros, more than $200 million. So in the next attack, I'm going to show you the hacker injects its malicious payload into the database, and as soon as he does, the victim doesn't know anything has happened, but his identity is stolen or he's been redirected to a malicious website. So let's see it live. So let's get back to the secure CRM website. And now I'll go to the Ask a Question page. And this page enables me to ask questions to the bank, and I can put the exact same payload I put before, but now it is being saved as a new question. And if this is vulnerable, you would see that I'm an innocent customer. I go here, I go there. Oh, I need to ask a question. I click it, and boom, I'm attacked. There is absolutely no sign for this to happen. So this is the more dangerous part of cross-site scripting, the dangerous form of cross-site scripting. Okay, so let us reset the Ask a Question page. Unfortunately, this does not occur in real website, but you go to reset.spx and all pain go away. So the last attack I want to show you is that of a malicious file upload. You probably noticed that the Ask a Question page contains, you can add your question and also attach a file to it, an attachment. So I can, for example, try to upload a malicious file, and if I am successful, perhaps I will be able to get to fully take over the secure CRM server and to do pretty much whatever I want. So let's see it live. So here you can see that I can, for example, upload my own image or a malicious file. So let's try the malicious file first. Invalid file type. Okay. And if I try to upload a picture, you can see that it is successfully uploaded. But if I take a look at the backstage of these two requests, I'll see the difference between them. So this is a proxy utility called burp. A proxy utility is a small utility that you redirect all of the communication from your browser to this utility, and it enables you to see it and to modify it before it leaves your computer. And these are the two upload requests. So this is the first one, and you can see here, this is the malicious file that I was trying to upload and the content type of it. And this is the second one, the image. This is an image, and this is the file name. But this field, the content type field, this is actually a metadata field that is assigned by the browser. The browser itself sees what the extension of the file is, and it assigns a corresponding content type as part of the uploaded file. And if the programmer actually relayed on this field in order to perform its input validation, perhaps I can modify the content type in order to upload a malicious file. So let's try it now. So I'm going to intercept the next request. And I'm going to try to upload my malicious file once again. But this time, I'm going to forge the content type and say, hey, this is just an image. Don't bother me. And if I'm lucky, you can see my malicious file was just uploaded. And it gives me the ability, for example, to upload a web shell. A web shell is a web page that allows me to full web access to the server. So I can, for example, full command line access via web. So I can, for example, go and check files in directories in the hacked server. And I can also read the content of different files. And if I have the proper privileges, I can also execute commands. And as you can see here, the command was successfully executed, and this means that I practically own this server now. So this is the secured CRM website, but now I'm going to try the exact same attack that I just showed you, but not for the secured CRM website, but against the really secured CRM website. And this site is actually protected by Microsoft Web Application Firewall and many other tools that Giuseppe is going to show you later on. So I'm going to try to do the exact same set of attacks. For example, this one. And you can see that I am blocked. And if I'll try cross-site scripting, I would be also blocked. And also SQL injection here would be blocked. And the persistent XSS here. Everything is blocked. Let's just reset the Ask a Question page. But one attack that is harder to block is the malicious file upload attack. I can still try to upload my malicious file. Let us do this quickly once again. And you can see that although I'm using Web Application Firewall, the attack, the file is still uploaded, but there are monitoring rules that you can configure in order to at least alert about a suspected web shell that was uploaded to one of your servers. And if I go to the web shell and try it, for example, to perform the ping command once again, you would see that I'm also blocked. So I was able to upload my web shell. I'm not able to fully operate it. Some functionality will work, some will be identified as a malicious activity and would be blocked by Web Application Firewall, but Giuseppe is going to show it later on. But let's move on to the mitigation part, but we'll start with the development. As I told you at the beginning, you need to fix your code. Even if you have web application firewalls and other measures that Giuseppe is going to show you later on, you still need to fix your code in order to fully mitigate all of the vulnerabilities that I just showed you. And in order to do so, there is a great methodology that was created by Microsoft that is called Security Development Lifecycle. When you create any product, software product, you have different stages: requirement, design, implementation, coding, verification, QA, release, etc. And Microsoft created a methodology that each and every step alongside the product lifecycle, you have the corresponding security steps that you need to do in order to reduce the number of risks and vulnerabilities in the final product that you release. So this is a great source of knowledge that I highly recommend you to go and see. And you probably think, okay, but this is the way that waterfall development was implemented with different steps which are very long, and you could do each and every step. But I'm going to show you in the next slide what Microsoft adapted this for modern development steps. But for waterfall, for each and every step along the product lifecycle, you have security requirements. These are just a few examples. When you start with the requirements of the product, you can, for example, define the security requirements as well, and maybe think about using a third-party provider for credit cards handling instead of saving it in your database. When you start the design, you have more detailed design requirements. Maybe you need a web application firewall or a database firewall. When you start the implementation phase and start the coding practices, you have also different steps for example, the manual and automated code review. This is not optional anymore. In the original SDL, it was optional, but now it is pretty much standard. So you can activate automated code review tools and integrate it into your DevOps operation, automatic code review that will run during the nighttime. During the verification test phase, in parallel to the QA phase, you can, for example, perform penetration tests, which also became a well-known standard for the verification phase. That hackers like the one inside try to penetrate into your system and to give you a full report of the vulnerabilities. And after your product is released, you can have, for example, an incident response plan. And again, this is a waterfall approach, and Microsoft adopted it to the agile world. So you cannot do, in agile, you don't have very long steps like in the waterfall development methodology, and you have very short sprints, 1 week, 2 weeks max, and you cannot do all of the different steps in each and every sprint. So Microsoft created the Agile SDL, and they defined 3 types of requirements. Every sprint requirement, which are requirements that you need to do each and every sprint, although you don't have a lot of time, you still need to do it because it is very important. Bucket requirements, these are requirements you do every once in a while, not in every sprint, but every few sprints. And one-time requirements, you do it once, usually at the beginning of your product lifecycle. This is usually a baseline, for example, a risk assessment baseline, and you update it every once in a while to make sure that your documentation and your is up to date. So this is Microsoft Agile SDL, and I highly recommend you to go to the website of Microsoft SDL and to read about it some more and to integrate some of these steps that I just showed you. Even some of these steps, not all of them, will greatly increase the security of your products and software. So I highly recommend you to show it. And the next part of the presentation would be that of Giuseppe, who would show you the mitigation part of the infrastructure and Microsoft infrastructure that prevented me from doing the same attack at the second phase, using, for example, web application firewall. So Giuseppe?
Yes, thank you, Gil. So let me share my screen again. Okay, do you see my screen?
Yes, we can see and hear you, Giuseppe.
Okay, thank you. Again, before jumping into the web interface to check all the components, we need to understand better which are the solutions we adopted in order to protect the environment. So the first one is the Azure Web Application Firewall. It is based on Application Gateway, and for who doesn't know, Application Gateway is a solution in Azure which balance VM, Azure App Service, and through a VPN, even the on-prem server. And it is the WAF is pre-configured with the OWASP top 10 rules, the core rule set called, and the connection is native with Azure Sentinel, our CM as a service. So pretty simple. And this is a SaaS solution. And like the other SaaS solution, it is have the auto-scaling support and is high availability with a native platform. Okay. Then we talked about Azure Sentinel. Azure Sentinel was mentioned in the first scenario by my colleague, and it is our CM and SOAR, our CM as a service, which means you don't need any kind of infrastructure to configure because it is in the cloud, ready to use. And the powerful of Azure Sentinel is that it is based on the artificial intelligence. So you can correlate the events, collect, and then investigate them using some playbooks to automate action and so on. Of a CM is to collect data sources as many as possible. And with Azure Sentinel, we can say that every source is available for the collection, starting from the Microsoft services, and I'm mentioning all the services you have seen in the previous scenarios. So Defender ATP, Azure ATP, and the Cloud App Security, and so on. But we can grab events from other clouds like Google, AWS. But last but not least, the open source and networking stuff using syslog collector and common event forwarding format. We can correlate all these sources, and after that create a custom dashboard to see some graphical representation. And using some query, we can investigate the content based on our correlation and create playbooks to automate action. All this kind of investigation or playbook is also useful to say that there is a community on GitHub that provide to the end user ready to use query in order to get more useful data from Sentinel. Azure Sentinel is based on log analytics. Log analytics is our data repository in the cloud, our solution, while Azure Sentinel provide custom elaboration in order to get more useful data. But let me jump into the protected scenario. We put on top of the backend, so our CRM, a web application firewall, and either the ESVM and the WAF have the event collected into Azure Sentinel. The web application firewall has the core rule set OWASP 3.0 configured by design, and some IPs filtering for restrict the IPs, the public IP. And the most important thing is that the CRM, the backend, has no direct internet connection. So this provide and restrict the attack surface of the VM. So let me jump into the interface. So this is the Azure dashboard. I think you know it, but this is the application gateway. And inside the application gateway, we created a new application gateway called WAF Demo 31. And we don't need to go deep dive into the every settings, of course, but the most important ones. The first in the backend pool. In the backend pool, I've configured the public IP where the HTTP requests will be forwarded. And the diagnostic settings provide a method to forward all the events to my log analytic workspace into Sentinel. Okay. Then the most important thing is the web application firewall. I created a policy applied to this web application firewall called Stop IPs. Stop IPs is a simple name to identify the policy, and I'm seeing two different rules. The first one is the managed rules, which include all the OWASP 3.0 core rule set, and I can expand all these IDs. I am able to see all the possible web application attack associated to this specific ID, and for the most curious people, you can go inside modsecurity.org and check for every request which are the protection associated to this kind of general rule. Okay, in the custom rule, I have two different custom rule. You can create a new one with a match type, for instance, a string, and inside the HTTP request, you can catch for something useful for you in order to create custom rules and protect a specific scenario. And well, the first one, my custom rule is block web shell. Block web shell is to identify and log, in this case, because as Gil said before, it's too difficult to match the upload of a remote shell, but we can identify possible commands associated to it. And again, filter allowed IP, which is the IP that is allowed to query our public WAF IP. Then jumping into the Sentinel workspaces, so which is Sentinel is just associated to a workspace, as I said before, and this is the dashboard. The most important thing is the data connector, the data sources. Based on the different connection, you can see the green where I have already connected some sources, and among this one, we have the web application firewall. Okay, so the connection was made, and the Azure diagnostic is the table which contains my logs of the web application firewall. Then I have built a specific rule for the SQL injection. I'm going through it to show you something. So SQL injection attack demo 31, severity high, the attacks which reflect the Mitre attacks framework. Then set the role logic. Sorry. The Azure diagnostic is the table which hosts which store the data of Sentinel, and where I can find this message inside the firewall log, so the detection of a SQL injection, I can create an alert and then create automated response. In this case, mitigate SQL injection could be a script or I don't know, other stuff to mitigate or identify this kind of attacks. And let me say, in this moment, I've implemented only a simple mail, which notified to me that a SQL injection was happened. And then I've created the rule. But after the attacks made by Gil, I have an incident. I have an incident which is demo SQL injection attack. And based on the query I wrote, I have 27 events which reflect with one IP and two URL. So if I'm going to click to investigate, I have the public IP involved in this kind of attack and the two contacts, the two pages which were involved in this kind of attack. So now I need to investigate more this one and go into logs. I have access to the database which contain all the logs, the log analytics workspace. So I can take this query. This is an example from the Azure Diagnostic, where time generated is 10 days is more, and 1 day, where the client IPs contain the public IP from which Gil did the attacks. And I click run, display time, local time, it's okay. I have all the attacks did by Gil, starting from the SQL injection, the classic SQL injection, and other attacks did by Gil. And the most important thing is the rule ID. Do you remember the rule ID is associated to the OWASP rules? And if I check which kind of rules match the Gil attacks, I can summarize it into charts and use the pie graph to check all the core rule set ID. I can imagine someone of you is thinking, but is almost not so understandable. We can substitute this with message and check in human readable format which kind of attacks were performed by Gil. Yes, that one. So we have XSS, SQL injection normal, different type of SQL injection, and so on. Okay, but if you remember, we collected also the logs from our machine. Okay, not only from the web application firewall. So we can rely on the GitHub portal for the Azure Sentinel to check if there is some interesting query to use for my IIS, which hosts my CRM. So I can go to the exploration queries, is an example. I have in this page a lot of useful data to use, so like query of detection, exploration queries, notebooks, playbooks, a lot of stuff, and especially the workbooks that we are going to talk in a few minutes. So I'm going to search for an exploration, for hunting queries to check more about the possibility of a code injection using the potential IIS code inject. This is a ready query for our log analytics workspace, and there is the description, the tactics which match the Mitre framework, and I convert it in a raw format, take the query from GitHub community and pass it into my log analytics interface. So run. This query catch all the all the events from the database or the table which contains the IIS VMs logs, and I'm able to see all the attacks performed or the code inject attacks tentative performed by Gil without the web application firewall. Okay. The last thing that I want to show you before ending this session is the workbook. The workbook is the graphical representation that is useful for us to immediately take a look about the events that are happening now. And based on the data sources, you have the possibility to choose different workbooks. Okay. For sure, we now select the web application firewall events. It's a standard dashboard. So view notebook, workbook, sorry. and restrict it to the, okay, let me say last 24 hours is enough. Okay, and we are able to see which blocked URL addresses, which kind of events were performed by Gil, the timeline, and the most interesting one, the number of SQL injection did by Gil, and all the attack events, sorry, and all the kind of SQL injection performed by Gil. Okay, and it was stopped. This is for the graphical part, let me say. And now I'm show you something interesting for the end of session. The Azure Sentinel is not based on a license. The cost of Sentinel is about space of data ingested. For if you want to use a Sentinel immediately, there is a free of charge if you ingest Office 365, Azure, or 365 security alerts from the Microsoft Cloud Security Platform. And of course, you don't have any infrastructure cost. And we know that for a CM, there is a lot of issue and a lot of, let me say, OPEX costs when you need to enlarge the disk space and allocate more space for more events. You don't have this kind of issue with a SaaS solution platform. So the cost effective is about pay as you go. Okay, but if you need to ingest more data, you can benefit about the capacity reservation to save up to the 60%. And if you are curious to check how much costs Azure Sentinel for you, you can click the link I've put in the slide to simulate the costs of Sentinel. Before the key takeaways, let me talk about the different strategy about our CRM. I imagine you have seen this slide many times. It is about the responsibility when you manage a service for different different platform in different cloud model service. For the on-prem part, of course, you're responsible for everything. But when you move up to the SaaS, you will benefit not only about the high availability, but even for the security part, because it's all about the risk. When you select to mitigate the risk, you can choose to transfer it to your cloud service provider, and or simply use the most advanced infrastructure security provided from your cloud service provider. Okay, so when you move to a SaaS platform for every service, I think, but especially for the CRM in this case, you will benefit to the infrastructure security that for sure is faster than yours in terms of capabilities of security. So key takeaways to end the session. As Gil said before, SDL is our top priorities when we develop code, but the web application firewall is at the second place because it's an additional best practice that for sure works well, but is not the top priority. Top priority is approach to the SDL. And as we can see, WAF can protect the internet and the hybrid scenario. Azure Sentinel helps us into the correlate events and for our security operations center. And at the end, we can leverage the SaaS CRM, or in general every SaaS solution, to benefit about the cloud security provided from our CSP. With that, grazie. Thank you. And let me switch over the voice to Yokai.
Thank you very much for this very interesting let's say demonstration of how to handle the attack CRM services. So with that, we are, let's say, covering our, let's say, core part of our webinar. And let me then pass the stick towards the closing remarks, right? And again, ask you if there are any questions that you would like us to answer. Please write in the Q&A session. I will try to take them.